welcome to another probability and statistics video. Today we're gonna talk about the Bayes theorem. The Bayes theorem calculates the posterior probability of a new event using a prior probability of some events. Basically, what the Bayes theorem do is to calculate probabilities of something that is going to happen in the future based upon previous data. The equation that we are going to be using is the next one. Let's explain it step by step. First, we have probability A over B, which means that the probability that A occurs knowing that B happens. Then on top we have the probability A, the probability that the event A occurs. Then we have the probability B divided by A, which is the opposite, probability that B happens knowing that A already did. And at the bottom we have probability B, which is the probability that the event B occurs. Let us consider this situation where a child has 3 bags of fruits. Okay, on the first bag we have 5 apples and 3 oranges. On the second bag we have 3 apples and 6 oranges. Third one, we have 2 apples and 3 oranges. Okay, then one fruit is drawn at random from one of the bags, and we know that it was an apple. But let us calculate the probability that the chosen fruit was an apple and was drawn from the third bag. Okay, as you can see, for this probability for Bayes theorem, we're going to be using it whenever we have a composition of probabilities. Here, for example, we're talking about the probability of the fruit to choose an apple and the probability of the bag. First of all, we need to consider the probability of selecting the bags. As you see, we have 3 bags. So for probability, on top we have the bag selected, and at the bottom we have the total of bags. Obviously, the probability is gonna set up as 1 out of 3. Then we need to set the probability of selecting an apple from each one of these bags. So it's gonna be the total amount of apples on top and divided by the total fruits inside of the bag. The first bag we have 5 apples out of 8 fruits. For the second bag we have 3 apples out of 9 different fruits, which can be simplified or reduced into 1 out of 3. And on the third bag we have 2 apples out of 5. Now once we have this, we need to get the probability of selecting an apple, but from the bag number 3. First of all, what is the information that we have so far? Well, we know that we have an apple. Okay, that's what we know. And what we need to get is the probability that the specific apple is being selected from the third bag. So the bag number 3 is what we're gonna have on top, and what we're gonna have at the bottom is gonna be the apple, because it's what we know that it has been selected already. So on top, we first need to consider the probability that the third bag was selected. That's why we start with probability of bag 3. Then we need to consider what's the probability to pick an apple from inside of that specific bag. So that's why we have probability of parentheses bag 3 divided by apple. And at the bottom, we need to consider the probability to pick all of the apples. So if we replace these values on top, the probability for us to pick the third bag is 1 out of 3. The probability to pick an apple from the third bag is 2 out of 5. At the bottom, to get the probability for us to pick an apple, we need to consider the apple from each one of the bags. From the first bag, the probability is 1 out of 3. And how many apples do we have in that bag? Well, 5 out of 8. Plus, now let's move on into the second bag. The probability is 1 out of 3 to pick that bag. And what is the probability to get an apple from the second bag? Well, 1 out of 3. Plus, the third one. The probability to pick the bag, we already have it on top of the formula, 1 out of 3. And the probability to pick an apple from the third bag is 2 out of 5. After doing this math operation, we get into 48 divided by 163, which can be reduced into 0.2945, or which is the same, around 29%. That's the probability that we can pick an apple from the third bag. Okay, let's move on into another example. For this one, we have a cell phone manufacturer company uses 2 different machines to produce them. The first one produces the 60%, and machine B, or the second one, produces the other 40%. The percentage of malfunctional devices for each machine is 5% and 10% respectively. We need to calculate what is the probability that the cell phone has been produced by machine A knowing that it's malfunctional? Okay, well, first of all, let's see what's the information that we have regarding the Bayes theorem formula. The question, it says, what is the probability that the cell phone has been produced by machine A? Okay, so that's what we're gonna place on top because that's what we need to get. Then it says that we know that it's malfunctional, so malfunctional will go at the bottom. As you see on top, first of all, we need to get the probability that the cell phone has been created by the machine A, and then we also need to know the probability that once we know that it has been produced by machine A, well, what's the probability that are malfunctional? And after that, we are going to divide everything into all of the malfunctional devices that we have. If we replace the values, the probability of the machine A is 60%, which is 0.6. The probability that it's malfunctional from the machine A is 5%, which is 0.05. The values that we have on top. And at the bottom, for all of the malfunctional devices, we're gonna have the malfunctional devices from the machine A plus the malfunctional devices from the machine B. From the machine A, we already have the values because they are the same of the ones we have on top. And for the machine B, we have a 40% probability that they are produced by the B machine, and just 10%, which is 0.1 probability that they are malfunctional. After we solve these operations, we're going to get something like 0.03 divided by 0.07, which gives us something near 0.4286, which can be rounded into 43%. This example can be explained by using another probability and statistic method, which is what we call the tree diagram. So for the tree diagram, we have a cell phone, and then the cell phone can be produced by two different machines. So we have two branches, A or B. The ones produced by A are the 60%, and the ones produced by B are the other 40% left. Remember that the branches for the tree diagram must give you an addition of 100% on each. After this, the production from A and B is going to split in two, the malfunctional devices and those who work correctly. For the malfunctional devices by A, we have our 5%, so 95% are correct. Then, for the production of the machine B, the malfunctional devices are the 10% and the correct ones are 90%. So we basically need to know what is the probability that we have malfunctional device from machine A, so that's what we're gonna have on top. And what we know is that it's malfunctional, so that's what we're gonna place at the bottom. So let's follow the direction or the path from the green instruction, which is the malfunctional from machine A. As you see, we first have the 60% probability and then the 5% probability. So those values are going to be placed on top. And at the bottom, we need to represent all of the malfunctional possibilities. So as you see, we have two different paths or directions. One from the production A and another one from the production B. So we need to add all of them. For the production A, we have 0.6 multiplied by 0.05, and for the production B, we have 0.4 multiplied by 0.1. This gives us the same answer, 0.03 divided by 0.07, which is something around 43%. As you see, there are two different ways to solve this type of probability problems. So that's it of probability and statistic Bayes theorem. Make sure to subscribe, like and share the video, and stay in touch for more math videos here in XMath. Goodbye.